Hello, everyone. My name is Susan Doniz. I am just absolutely thrilled to be with all of you here today to learn about data science. Specifically, I want to talk about how we use data science and IT to power today, predict tomorrow, and to innovate for the future. I am thrilled to be here with you, and hopefully you'll be able to take away some tidbits, not just for yourself today, maybe your future selves, but also to share with your colleagues. So the first question I usually get asked is, what does a chief information officer do anyway? And so let me talk about what I do as a chief information and data analytics officer. And I do believe many of my colleagues would share the same kind of responsibilities too. So essentially, there's not anything that runs in any company, I guarantee it, without IT and data analytics. So everything from your computer and plugging it in and connecting it to the internet, all the way through to how you get paid, how you order parts for your supply chain to get to your factory or to your home, and then also all the way through to how do you build things. So IT is interconnected and data analytics is used across everything we use in the company. I love what I do. I love what I do working for Boeing. I'm going to talk a little bit about what we do for Boeing, but we build some pretty inspiring products that help connect us to people across the globe to protect peace and freedom, and also to explore our world and beyond as well. So let's talk a little bit about what Boeing does. I hopefully know that you know a bit about the brand. But I think many people don't appreciate the breadth of the products that we support. And it's really important when I talk about the context of data science. The context that you work in is really important. And one of the things I would encourage you to always do is to make sure that you're understanding the context of your business, because context is everything. It is not just the execution. It is how we are thinking about embedding the execution in your environment. So at Boeing, we basically have three business units. The first one is a commercial airplane. Hopefully many of you have experienced these products before. It's products that fly you across to visit your loved ones, from the beloved 787, the 737, and even the 767 that delivers all of your home order deliveries as a freighter to your home and to your business. The other business unit that many of you might have heard about is defense, space, and security. So defense is everything from F-18 fighters to things like Chinooks, Apache helicopters, really amazing aircraft, all the way through things like the Starliner and SLS. SLS is something that we will use to power us to get to the moon and to Mars and to beyond. It is the most powerful rocket that has ever been built. So pretty complex environment. And the last one is services. So this helps us modify our aircraft, keep them safe, keep them up and running, but importantly, deliver parts to all of them, and lastly, to help run them. So a lot of our pilots and the crew use the tools to help understand airports and the safety in the air as well. So hopefully you've experienced some of our Boeing products, and if not, I hope you will have the delight and pleasure to experience them in the future. Perhaps we have a future astronaut in our midst as well here, and you can experience some of the defense, space, and security products. So under that context, I want to talk a little bit about what we do and why IT and data analytics is so important. I alluded to it at the very beginning. Nothing runs in this company without the IT and the data analytics. It is a key strategy for our future, because even though we will obviously continue R&D around metals and how we put our products together, the digital component of how we put our products together is critically important. The reason for that is these are very complex products with very low levels of error permitted. So it is beyond 6 sigma. It's 10 to the minus 9, which means that your error rate needs to be minimal. So when you can build things digitally many times over before you actually physically have to, it eliminates not just waste, but ongoing build and maintenance. Because often what happens is you design a very complex product and it is near to impossible to build it to specifications. In fact, in some cases, we use the 3D models and 3D printing to build our products because there is no machine or hands that can actually build a product in that manner. So hopefully that gives you a good example of how we use it. Also, a lot of our products are flown using digital enablement. So what that means is when you have an autonomous aircraft, it is flown through AI and machine learning. So this is all powered by data and analytics as well. So I hope you can appreciate how digital is firmly not just ensconced in everything we do, but how we think about our future. And I would say that most companies, when you hear about them speak, they're talking about being technology companies, data companies. And with new technologies, or rather they're not new, but technologies that are getting adapted and adopted, like generative AI. Generative AI has actually been around for a while. You'll see that companies are really looking at these technologies to help differentiate them. So let me talk a little bit about some of the examples of how we use that within Boeing. Hopefully you'll be thinking about the examples of how you use that within your own companies and what you're learning about potentially in university as well. And hopefully you'll be inspired to how that can be either different or how you can use that to create strategic advantage or to help grow, as I said, your customer delight across any business that you are supporting. So the first thing is that data powers everything. And I've been working in IT and data analytics for well over 20 years now. And I have to say some of the things that I learned early in my career still apply now, which is data and the quality of the data is important. If you have garbage data, no matter how many analytics or technology you put on top of it, it is not going to help because garbage in still equals garbage out. So that's why having a really great foundation around not just the quality of your data, but where your data is and how you can combine it is important. And I just want to illustrate that through an example. We have created a tool, and you can go online and use it. It's called the Cascade Climate Impact Tool. And essentially what it allows anybody to do, yourself, but it allows policymakers or CEOs that purchase aircraft to model what would their climate impact be to net zero emissions if they looked at different components, such as when they're going to renew their fleet, renewable energy sources, operational efficiency, advanced technology. So all of these using different levers, you can model what it would look like if you were using a hydrogen or an electric propulsion combined with all three of these different criteria. So what that allows you to do is to combine data internally that we have available at Boeing, but also externally, which is available across various industries. And that is really the power of data, is how you combine it to give you some insight, which is the last piece of work. It's not just the data, it's the insight. What are you going to do with the data is really critically important, because otherwise we're serving up a lot of data that either isn't actionable or that there's nobody there to action it. So we've built this tool in partnership with IATA, which is the Airline Association, NASA, and the University of Cambridge. So it's a really nice example of how industry will work across competitors, even universities, and not-for-profit organization to improve the outcome of our net zero emissions. And I'm fairly sure you can think of various examples in your industry of how putting the data together and collaborating will help you lead to better insights and outcomes. Another example I want to talk about is something you might have heard about, which is called the digital twin. Some of the data is also referred to as the Internet of Things. So let's talk a little bit about what that is and what it means. So basically it means, how do you create something in the virtual world that is the same as what it would be in the physical world? So what you have to do that is you actually have to have something that in the industry we would refer to as the digital thread. I like to call it the digital fabric, because a thread is very thin and has one single line, whereas a fabric is all these threads woven together. So essentially what it means is, how do you pass information from various systems? Because when you look at a digital thread, for example, factory automation, you want to be able to develop your airplane or your helicopter or your Starliner various times before you start to build it. Because in some of these cases, for example, the Starliner, we don't create hundreds of copies. We create a very few copies. So it means that each one needs to be literally perfect. So remember, 10 to the -9, not even a human hair can fit into some of the wedges where they're not supposed to fit into. So in order to do that, you have various systems, because the amount of data that we use to integrate is terabytes of data. Terabytes of data is a lot of data. It means, I think once I looked at it, it was like watching movies continuously for a year. So that's the amount of data that is going through some of our products in our aircraft. So in order to do that, you have to link all the systems together with all of the data. So in order to do that, what we do is we have all sorts of digital tools that allow them to design the aircraft, but also to understand how would you build it. And you go through various iterations of this till you come up with something that can be built in the way that is designed. And you can actually test it millions of times before you fly it. Because when you physically test things, there's only so many different things you can do. Throwing chickens into the air and flying through them. You can do this hundreds of times virtually, and before you have to do it physically, and you can test these things too. We even test some of these, the way the wind works and moves. Before, the way we used to do it is you would hang little strings from the aircraft and look at it through a wind tunnel. Actually, now we can digitally model, actually using AI and machine learning, how those little strings would flow into the air. So we actually don't need to do that as many times. Another great example is airplane wiring. Hopefully you've seen wiring in different mechanical devices in your life. But when you look at some of these devices in your computer, you'll see that some of them are very tiny. When you look at them in an aircraft, some of them are tiny and some of them are huge. And the complexity of the number of wires that have to go through, but also how you have to ground the wires and how they need to be separated and how you test them, is actually very complicated. So if you've ever had to build something in your house, like an IKEA bookshelf, for example, you'll understand that it's complicated to look at a 2D drawing and then try to make it in a 3D output. And so what we use is virtual reality lenses. There's lots of different companies that produce them. And what it allows is the mechanic to see what the drawing should look like and where it should be, and if it is misaligned with what it looks like. So imagine, you putting together your IKEA bookshelf and seeing that you've actually done something incorrectly as you do it, versus when you've put it all together and you need to take it all apart. So that's the kind of things that we use the digital twin for. And then the last example I want to talk about, as I said previously too, You can't get through any article or any news feed without hearing something about generative AI. And I just want to take a step back, which is I talked a little bit about, having the data, curating the data is really important, but also asking the right questions. And if you've experimented with generative AI, what you will know is actually the better you are at asking the right questions, the better outcome you will get, which is the reason why oftentimes in technologies like generative AI that can create new insights through via complex data that's coming into it and simplifying it, you actually are positively impacted by having somebody who knows a little bit more about it. Because when you know something about something, you can ask better questions, which goes back to my comment at the beginning, which is content and understanding your content and your context is really important, because the more you understand it, the more nuanced you can be with the questions that you're asking. We're using it, a lot of companies are using it from everything from coding to also just even helping us do research. One of the things that we've been very focused on, and I would encourage you all to think about this too, is you've got to put the human in the middle of all of this. So it's the human that still has the right judgment. There's something in generative AI called hallucinations. You've got to make sure that you've got somebody looking through this that has the right judgment, has asked the right questions, but also can filter through it to make sure that the output we're getting is accurate. So just in terms of wrapping up, I just want to talk about a little bit about my leadership lessons. Hopefully it'll resonate with many of you. I've had a career, as I said, over 20 years in technology. And I have to say the most important thing I can tell you about technology is it's about the human, sometimes more than it is about the technology. Managing change and getting people to adopt and adapt to new work processes, because in general, when you're implementing a new technology, you're changing the way people work, is really important. So understanding the psychology about how people want to adopt change is really important. And again, it goes back to understanding the processes and how everybody works through the processes versus just understanding how the machine would do it. I'm telling you, that's where projects fail, is because we all think we're machines and we'll follow instructions perfectly. And there's a lot of science behind what motivates people to change and what motivates people to do things differently. So I would really encourage you to look at user-centric design. One of my biggest learnings is, in my case, it's walk the factory floor. If you're closer to customers, make sure that you're observing how customers interact with your products and what they do, because that is a big source of not just innovation, but a big source to understand how people will adopt new technologies. They won't just do it because you say it's better. They'll do it because it provides a significant benefit for them. I find, people don't want to change if it's 10% better. They want to change when it's 50% better. The other thing I want to talk about is focusing on leadership is about being inspired, but also being able to execute, because people will follow you when they see that you've got an inspiring mission and when you engage them in it. It's not necessarily about who reports to who anymore. And so I would just encourage you again to make sure that you are being empathetic with your users, because you will find that you will get a lot more people along in your journey with you when you're starting it with the human in the center of it all. So with that, I will end here. I will hope that you took something away from this. I will hope you will think about your future and how you enable technology or use technology and data analytics to improve the outcomes of your company, of our planet, of the employees that you work with. But you also think about this in terms of diversity and inclusion, as well as how can you make everybody have their best day in the office or outside of the office by using these tools. I'm also incredibly proud that Boeing offers wonderful internship programs, as many companies do. And if you're in university, or you're lucky enough to be in university and at the start of your career, I would definitely encourage you to look at different internship programs as well, so you can experience some of these things firsthand. So thank you, everyone.